Hello everyone, and Happy New Year to those who are watching on the Pacific Coast. Let's get to today's daily challenge. 456 assign cookies. And this is an easy level question. Let's get to the description. Assume you're an awesome parent and want to give your children some cookies, but you should give each child at most one cookie. Okay. So each child I has a greed factor, G, I, where the minimum size of a cookie that is the child will be content with. Okay, so we have this array, G, that says what is the minimum size of a cookie that the child will be content with. And each cookie, J, has a size Sj. So then we're given another array of sizes, S, where J is just a cookie, and S of J is the size of that cookie. If S of J is greater than the greed of I of a child, we assign the cookie J to the child I. If the child I, and the child I will be content. Your goal is to maximize the number of content children and compute the maximum number. Alright, let's put this in my own words. We have a bunch of kids, and we're a parent that wants to distribute cookies between those kids. Now, what I want to maximize is the number of content kids. And since all the kids are different, they have these greed factors, which represent the how greedy they are. If a child is very greedy, then they would want a very big cookie. And if we have a very big cookie, then we can satisfy that child. If not, then the child is not going to be satisfied. Our goal is to figure out how many children we can satisfy. Alright, and then we have some examples. We have the greed array 1, 2, 3, meaning that we have 3 kids and their greed factors are 1, 2, 3, and we have 2 cookies, both of size 1. Well, we can only satisfy 1 kid. The output is 1. You have 3 kids, 2 cookies, the greed factor of the 3 children are 1, 2, 3. And even though you have 2 cookies, since the size are both 1, the size is both 1, you can only make the child whose greed factor 1 content. You need to output 1. Alright, and then we have another example, 1, 2, and 1, 2, 3. So we have 2 kids, 3 cookies, and guess what? We can make all of those kids happy. The output is 2. We assign cookie 1 to the kid whose greed factor is 1, and 2 to the greed factor 2. Or we can assign 2, 3 to these 2 kids. Alright, well, what's happening here? It doesn't claim that the arrays are sorted, but what we really should be considering is who are the most greedy or the least greedy kids, and who are the most greedy kids. Now, we should prioritize getting the not so greedy kids satisfied or content first, and we should probably consider getting them satisfied with the smallest cookies possible. So let's first sort these 2 arrays, and G sort and S sort should do the trick. Now, what do we need to do? We need to iterate over the cookies and try to see who can we give this cookie to. So if we have cookie 1, we're going to attempt to give it to as many kids as possible, or to the kid. We're going to try to assign it to the kid who is the least greediest. So content kids will have a variable that measures, that actually is the output, and then we'll have what else? Maybe like kid IDX, so the kid index for cookie in what? In S, we want to see if cookie is greater than or equal to the kid index, which represents their greed factor, then increment the number of content kids and increment the kid index. So we're going to move on to trying to satisfy the next kid. Let's return the number of content kids, and that should be it. Let's run this and see if this works. Now there's one more situation where you could potentially exceed the number of kids that you want to satisfy. So if we have 3 cookies but only 2 kids, we're actually going to, oh, and we're satisfying all of them, we're going to get an index out of bounds. So let's do another thing here. If cookie index less than length, and let's have a L here, len of the greed. So if we have this, and this should be good. And looks like we're good. We're set. All right, this is the first submission of 2024. Let's see if we can get a reaction. Cool. All right. Well, thanks for watching. Hope this was an easy solution. And a good explanation. We're in the 99th percentile, so we're good there. Cool. Thanks for watching. See you later. Please like and subscribe. Helps out the channel. Bye.